And next we have a panel discussion. We have almost 6 speakers who's going to take this part. So let me brief about them as well the topics they are going to discuss here. So panel discussion on the topic that is enhancing sensor technology for India's diverse road conditions by Moderator, Mr. Praveen, Pothumahanty, partner EY-Parthenon. So Praveen has mastered the art of merging technology with a strategy to deliver exceptional results to clients worldwide. With an impressive 15 years of global experience in both automotive technology and management consulting, he brings a wealth of expertise to the table. So you are requesting, please. And next topic we have adopting LiDAR for Indian roads, balancing performance and cost in varied environments by Martin Fritz, CEO, 4 Active Systems. 4 Active Systems is at the forefront of active vehicle safety, focusing its expertise on state-of-art testing technologies to evaluate and improve traffic safety. VR has committed to setting new industry standards and continuously improving his products and process to meet the requirements of organizations such as ISO, NCAP, and UNCE. So you are requesting on stage, please. And next topic we have, that is the role of radar in detecting obstacles in challenging Indian weather conditions by Fabian Engemann, Field Application Engineer, dSPACE Headquarters. So Fabian Engemann is a seasoned field application engineer at dSPACE Headquarters, where he plays a guiding role in data-driven development and ADAS validation projects. With a master's degree in electrical engineering from the University of Paderborn, Germany, and Kohoku University in Sedan, Japan. So Fabian has specialized in machine learning and has extensive practical experience in his field. And the next topic, that is improving camera systems for better object and pedestrian recognition in crowded urban areas by Balamanikandan M, Principal Architect, CARIAD, India. Sir, you are requesting on stage. So he's a technical leader with 19 plus years of experience in safety critical embedded system on software development in automotive and avionics domain. Currently, he is working in CARIAD India as a principal architect, and he'll be responsible for all the technical topics in ADAS AD software development. And the next topic is ultrasonic sensors for close range reduction in light traffic and parking scenarios. It is going to be discussed by Mr. Aneesh Gopinathan, who is the head of product line Radar Sensor Autonomous Mobility, AM, Continental Autonomous Mobility India Private Limited. You are requested, sir. So Aneesh brings nearly 20 years of diverse experience in the automotive industry, spanning interior, active safety systems, and autonomous mobility. Since joining Continental in 2014, he has built expertise in system integration, hardware engineering, and vehicle test, and currently serves as the product head for Continental's global radar business, leading the product line in India since 2022. He holds a bachelor degree in computer science and has previously worked with Tata Ells, Renault Nissan, and Delphi India. And the last topic, that is integrating sensor data to handle unpredictable road conditions and mixed traffic in India by Mr. Sreeram S, Director, Automated Driving and ADAS Software Development, BOSCH. Sir, you are requested on stage. So, Mr. Sreeram S is a technology leader with over 23 years of experience in managing complex projects and driving innovation in various domains in automotive sector. Currently, he is playing the role Director of Automated Driving and ADAS Software Development at BOSCH Global Software Technologies. Thank you so much. All my dear speakers, over to you.
So good morning everyone. Hearty welcome to my co-panelists over here. We have 1 hour budgeted for this session, but given that we are already running behind, we will probably give back 10 minutes and we will try to close it in 50 minutes, whatever we wanted to discuss today in this session, right? So maybe Fabian, if we begin with you, especially on the radar technology side of things, and given that you've spent some time in India now, right? What has been your learning on using radar in the Western markets? And how do you see, how do we adapt them to the Indian driving conditions? I think the previous presentation briefly touched upon that, but we'd like to hear your initial thoughts on this topic.
Yes, thanks for the question and thanks for having me. Well, first of all, you see, of course, big differences in like how the logic of the traffic, you could say. I mean, it was part of the previous session as well. So, first of all, I think if we're building ADAS systems like ACC or emergency braking or something, I don't see any system running here in India without radar in there. So, I mean, it's works in any weather conditions, and it's pretty cheap, and it's also a technology which is also pretty advanced and like pretty stable on the market already. However, I do see big problems. We were talking about data collection, for example. So we need really the data from the Indian market directly, from Indian streets, because they're fundamentally different. But building up this kind of your own data lake, basically, this needs to be addressed. Here today we have, I see many players on the market doing this, but in the beginning, I see a lot of projects, people going in there quite naively, and okay, then suddenly they find out that 90% of the data, for example, is just redundant. So we really need efficient solutions to filter out the right kinds of data in there. And yeah, so one thing to address. Second thing is, I mean, the speech before us was about having an AI doing the decisions of the ACC, for example. But then I'm directly asking myself, okay, who's doing the testing? How much do we need to test the AI? Because, I mean, that, of course, would be some kind of black box model. And in any case, the testing of that would need to start as early as possible. So some kind of left shift in order to do as much testing as possible. So yeah, that's my point.
Thanks, Fabian. And Aneesh, if you want to add on to that basis, your experience on radar and in your company, and in terms of how you've been doing that.
Exactly. So I would say 2-3 thoughts basically. So from an Indian perspective, we have worked a lot about radars. So cost is right on target, no problem there. Excellent in weather conditions, in typical Indian conditions. The topic, what like he mentioned also, is very clear. The use case from India is completely different. So how we are collecting data from the Indian roads, it's not just about the driving data, maximize the virtual simulations. So use simulations as much as possible regarding the use cases, get more driving data, and use AI models to train your algorithm. So this is the best approach. And another thought is, again, when we talk to many people regarding the tuning towards Indian conditions. So many people perceive this as just the function parameter tuning. So this is not enough, majority of the cases. So the tuning of parameters is not enough to work certain functions in Indian conditions. So the whole perception chain has to be adapted many times. So hardware, mechanics, cost, these are all okay, but in the software stack, you need to adapt these topics. So if we have an inherent sensing problem using radar, this cannot be changed in a function. So in the whole chain of events, you need to correct these softwares. You sometimes may need to design, sometimes may need to adapt to the Indian conditions. Especially like the previous speakers pointed out, the variety of conditions like the two-wheelers. So if I can give a simple data point, we have compared the ACC function against a European road and Indian road. We can clearly see the data, the performance metrics is 7 to 10 times more worse here. And 30%, 40% of these false positives exactly are due to the motorcycles. So these are the challenges in Indian road. There are people working towards it. I hope we can really address these challenges in the future.
So we'll come back to radars a little bit later in the conversation. If you switch gears now, and maybe again I'll come back to you, Anish, the ultrasonic sensors have been in the market for quite some time, even in the Indian market for different kinds of applications, especially park assist, for example. Where do you see the future of those sensors going forward? And you know, there is a talk that some of these sensors might eventually get replaced by radar as well, right? So two questions. One is, where is the ultrasonics going from a sensor point of view in the Indian market? What new features will come on basis existing sensors? And then what is the risk of them becoming redundant if radar takes over?
As we all know, ultrasonic sensors are immensely popular in India, even before the widespread ADAS technology adoption, due to the distance-based warning systems. But recently with the ADAS technology, mainly due to the automated parking applications, ultrasonics are really relevant. So what we can see now, ultrasonics are majorly used for automated parking solutions, mainly by the top OEMs, and this will continue to grow. At the same time, we see Indian challenges there also. So it can be broadly categorized into the classical sensing problems of ultrasonics, maybe a small round metal pole, for example, and what you call the non-standard objects, and the kind of inaccuracy in the height estimation, etc. So there are challenges in the Indian scenarios also for ultrasonics. And there are some ways to overcome it, again, using data, AI, and other topics, using the algorithms. But as you mentioned, at least in the premium market of ADAS, we see a trend emerging using the higher bandwidth of radar, which means the 77 to 81 gigahertz of radar. We can solve some of these parking challenges. So if in the premium market, if there is a, let's say, car equipped with radar sensors, and the same radar sensor can perform the parking maneuvers. So this trend will go to continue in the, at least in the premium markets, but due to cost reasons may not be in the volume markets, of course.
Thanks, Aneesh, for your thoughts on ultrasonics. So if we switch gears now, we've looked at radar, we've heard some initial thoughts on ultrasonics as well. Maybe if I bring you in, Bala, here in terms of what are your initial thoughts on how the vision-based systems, the camera-based systems are evolving in terms of their accuracy, in terms of the reliability, and what new technologies that we can look forward to globally and also with relevance to the Indian market, for example?
If you look at historically, camera-based systems are complemented the radar. For example, radar will not be able to detect the classification correctly for functions such as lane detection, traffic light. So camera is necessary. Then if you look at, as previous speaker mentioned about the advancement in the AI, so camera also, like there are AI systems in camera which very well can do the speed estimation and distance estimation, which was not the case some years ago when first ADAS function introduced. So I see that, so for India, if you look at the India scenarios, morning we spoke about different challenges, and the one word that you have also used is very dynamic and unpredictable. So what that means for India is that we need a system so that can do the perception at very low latency, and we need high performance system. So I see that there are developments happening from this perspective, something called event-based camera, so which can, with low latency of 1 millisecond, probably that could be one solution together with mono camera such that it can predict the driver unpredictable pedestrian movement, two-wheeler crossing and auto rickshaws cutting. So I see that A is the solution, but everybody spoke about also the data collection, right? So what I get is today, simply, if you look at historically, we follow the solution coming from the Europe or the global market, which they developed for their NCAP requirement, their regulation requirement, not for the India regulation. We don't even have a regulation yet. So that means that taking over, as Aneesh spoke about, calibration alone not sufficient, because calibration still, I do the calibration for the rule-based solution. But then we are talking about the AI-based solution, because rule-based solution may not work for the India conditions all the time. And reaching such a level of infrastructure as in the Western world, maybe it is a dream, or we do not know it is going to take how long time. We can't change the people behavior all of a sudden. So, but what we have to bring is bring more of AI-based solution in camera, because there are OEMs who are talking about vision only, L3 and L4 system. And today we already see that L2 system is becoming a common. So as you all know that first L2 system got introduced to the market in 2021 or 2022, and I see that even the C segment cars having ADAS function with L2 is very common now, right? So that means that there is a high potential for us to do the data collection, because everybody talk about data collection morning, right? And also the previous speaker. So the data collection is important, and the data coming from the India market, calibration, tuning or learning AI model for the India market is very much important. That is where the solution comes for the India. And on top of it, see, we also talk about the other ISO standards, say 23150, which talks about standard interfaces, because people talk about validation. So they take a reference from the ISO standard, which defines the standard types. So let's say simple object types. It talks about all the objects that you see in the Western world, but not in India. So even we have a very unique case where the disabled people use a different kind of wheelchair, not really wheelchair that you see in the hospital or in the Western world. It is a unconventional. We see that people are crossing on the road, right? So that means that we have to also work with ISO, talk about the standards that are needed, different regulations that are needed for India, and that is where I see solution. Okay, so why all it is important? Because we talk about the data and learning from the camera perspective. Yeah. So
I think adding object classification types, more types which are suited to the Indian environmental conditions, which are not there as a part of the standard list, that is something you see as an important step. Thank you very much for that thought. So Martin, if I come to you to maybe this is something in the Indian market which may or may not ever happen, which is the LiDAR systems, given the kind of, we are not really talking about autonomy over here. We are only thinking about ADAS from safety perspective, and we may not, autonomous driving is quite away for this particular market. But I want to hear your initial thoughts on, how is LiDAR enabling ADAS globally, right? And if you were to make a prediction of, if LiDAR were ever to come into this market, how would LiDAR be different in this market or used differently in this market as compared to, the other markets, for example?
Okay, thank you very much for the question. As everyone knows, LiDAR is a very expensive technology, but is the base for autonomous driving. Also in Europe, we thought, as we heard from some speeches already, now we are already in Europe, everyone drives autonomous cars. 10 years ago, 20 years ago. So it will not be happen so fast, but it will happen. And also for India, if we're looking 20, 30 years, maybe into the future, maybe this will then be a good sensor type, because a LiDAR system can making really perfect 3D mapping, so the car knows exactly where it is. You can detect 20 to 30 objects in parallel, you can classify. So it is a very good system, has also some weak points, the costs for sure, and also during foggy situations, LiDAR cannot look through fog. Radar can look through it. And this is something, I think, from the Indian market too early, the next 10 to 15 years. But finally, it will be a solution for the far future.
And do you want to take a guess? Is it going to be a solution in 2035, 2045 in this market, or even longer?
So for this market, I don't know. I think you will be very fast. But maybe the safety, vehicle safety, has some components which are not only related to ADAS, autonomous driving. So you have passive safety, which is still very important. You have road conditions. You have rules. So if you think to follow the Vision Zero, which is coming from Sweden, from Volvo, So no deaths on the on the road. This is a vision, illusion, whatever. But you can only reach if every component is working each other. Also, ADAS systems are really working good if the road conditions, lane markings are perfect. So also that you focus on each point for driver assistance. Yeah.
Thanks, Martin. So Sreeram, if you move away from the topic of sensors and sensing and hardware, would you maybe elaborate on the role software has to play in bringing all of these things together, in making all of these sensors working together so that you're able to deliver those features to the end customer and make sure that everything seems to be very seamless? You know, what is the kind of role you see software playing going forward in terms of advancing ADAS systems in the Indian context and also globally? For example, we had a conversation about AI in terms of training the sensors and so on and so forth. But if you start with the role of software in bringing all of this sensor information together, creating the environment, and then maybe the future in terms of how AI is going to play a major role in taking all of this forward.
Yeah. Thanks, Praveen. So if you look at it, the shift of automotive industry happened with the introduction of ADAS, where the automotive companies started thinking that we should be better software companies, right? And ADAS was the trigger. Of course, infotainment was there in the beginning, but ADAS was what actually brought about that shift. And why is it so? So if you look at sensing, right? Sensing is only part of it. When you move from sensing to perception, it's basically creating a model of the environment around you, taking the data that is collected from these sensors, and it's purely software, right? So just as an example, when we were looking at these Indian conditions, I came across a picture where you have a footpath and the person is walking, and then you have an electric pole on the footpath, right? And now a classic reaction is that he will get onto the road, right? In a European scenario, you don't have a pole on the footpath that the guy has to get onto the road, right? And it's a pretty Indian situation. So the classical approach for pedestrian behavior is to use standard kinematics to see how does his path look like. If you apply that, you will feel that the person will come onto the road, and then you have to apply brake or have an intervention. But in an Indian scenario, he may not come onto the road because he just want to avoid that electric pole on the footpath, and he just have to go around it, right? And it's not possible to use standard kinematics to define that kind of a behavior. You need to bring more sophisticated software to handle that kind of situations. And that is where AI and data-driven development comes into picture, right? And all of the panelists were also talking about how AI plays a big role. The advantage of bringing AI is that you don't really have to design the software. You can bring in data to solve problems, right? It just means that you have to have the best data pipelines in place, right? So you have to have mechanisms that the vehicles can record data, the relevant data, bring it back, because just blind recording of data is also too expensive because it's the storage cost and so on. So you need to build softwares that can bring in the right data, and then you have to have the pipelines which are bringing that data to the model that is getting trained, right? And one instance of data is not enough. So if you just have one person crossing the road, it's like you are generalizing for one behavior, right? So now you have to look for similar behaviors across. And you need to have data collection mechanisms which will trigger for such behaviors. That data is brought in, and the speed with which you can collect data, and that data can be used to improve your performance of your AI model. That is actually what makes the difference. And this is completely software. And it's not even edge software, it is basically software that runs on the cloud. Because except for the filter that is on the sensor that is in a vehicle or the computer in the vehicle, everything is running on the cloud. And that's the importance of software in ADAS development. Of course, the software that runs on the edge, on the compute device in the vehicle is also complex, but it's much more than standard classical embedded software. It's beyond that. And that's the transformation that has happened to automotive industry with the introduction of ADAS. And that's what defines your success or failure, the best data pipelines that you can build and the speed with which you can keep improving your models to meet the real life situations that you encounter on the road. And that's how we can design the right ADAS system for India.
Just staying on the topic, the previous presentation from Zendar, I think they talk about a fundamental change in the architecture in itself in terms of how you're computing data and how you're kind of changing what, because you said even picking up data is an expensive thing. You don't want to keep recording data if it is not required and not processing the data. How do you see that evolving, you know, because the requirements are going to get more and more stringent. People want to keep sensing more and more stuff. Perception needs to improve. Therefore, the processing needs to improve. Do you think there's a fundamental rethink of how an ADAS architecture is done today versus how it may be done in the future? You know, splitting between radar and vision-based systems and trying to split the computational power required between, you know, on-the-chip, high performance, and then in the cloud, and how do you think about those architectures evolving? Because right now it has been a linear architecture, rule-based architecture, but maybe going forward it will be a lot more AI, and it will be, you know, you kind of make a judgment call, am I processing this data here with this sensor or that sensor? Am I sensing this with this sensor or that sensor, so that I keep my costs down and I keep my, without compromising on the processing quality or without compromising on the output that you're getting? How do you see that evolving from a system architecture perspective?
Yeah, the switch from rule-based has already started to happen. It's rule-based is a little, so for example, when ADAS started, everything was rule-based. Even computer vision was classical machine learning-based. Even radar is classical approaches to do perception, right? And the stack moved from conventional rule-based to more data and AI-based, started with perception. So because that was the biggest problem to address, and the most complex, perception was the most complex problem to address, and they wanted to bring in data into that. And the first architectural change was to bring AI into re-architecting the way you do perception. But going forward, as the first, then it would be like you have object detected using the AI methods, but you have conventional methods for fusing it and then doing your behavior, driving policy, and so on. But the latest trend is that you bring in AI into all these aspects of the stack, right? As in the previous presentation, they spoke about an end-to-end AI, where you just feed the spectrum and you get maybe your steering angle or something as the output. That's the idea of end-to-end. That's the way it is evolving, but the step-by-step improvement or the change that we are seeing in the larger architecture is that you bring in AI into all these elements of the stack itself. So not just with perception, as the next level you have multimodal fusion that is happening. You could have AI models which could fuse inputs that coming, the basic information that is coming from different sensor modalities like the cameras, the radars, the lidars, or whatever it is. And then you get a temporal tracked object which is basically coming out of an AI model, right? And then you could also have AI methods for traffic participation modeling. Like, for example, you see a car coming in or a pedestrian coming, you can have a model that predicts what could be his path, right? And then you could also feed that information into a model, and the model can predict what should be your driving strategy, what would be your path or the trajectory itself, right? And that's how we see the larger technology landscape and the architecture in ADAS evolving. And that's how it has to be, because as we move more towards the data-driven approach in development, it becomes easier to handle complex cases, because you can bring in data to solve problem. You don't have to really define a rule for different driving scenarios. And that's how we see that evolving.
Thanks, Sreeram. So switching to this side now, maybe Fabian, if I can bring you in terms of, what are the different kind of test cases you see which are different to the Indian market, from the kind of work that you do, especially from an ADAS point of view. This is something you wouldn't have done in your work for European clients, but if you're doing it for the Indian clients with respect to some ADAS sensors or ADAS technology, the simulation of various test cases or defining the various test cases which are more relevant to the Indian condition, what has your experience been on that side of things?
So, I mean, as you probably know, we can do all kinds of different types of tests. So, of course, onboard testing is still existent, will never go away. We have HL testing, we've got testing in SIL environment, and we can do testing in clouds, and kind of mixture cases, of course, always exist. And, I mean, if we're talking about bringing in more AI algorithms into all of this, for example, perception tasks, prediction parts, everything like this, I'm, again, thinking about how can we actually make sure that these intermediate steps are actually working correct. So, yeah, again, how to do a valid kind of testing there in these cases. To be honest, it's, yeah, the whole thing must start with a kind of holistic approach holistic testing approach. You cannot do just, okay, I only do HL testing and that will be it. So you always have to take parts of your algorithm, for example, take the prediction part, great thing which you can test in simulation. However, for example, the object detection, there it's way more effort to make a realistic simulation, to have all kinds of 3D environments, have a 3D rickshaw going through the scenario, for example. Here in these cases, it's way more easier to use like real-world data, of course. But I think the main issue actually starts way earlier in how do we define what are the right scenarios to test. So if give me enough time and some money, I can get the best simulator, I can get people to build me scenarios to test. That's not a problem. But who can tell me what exactly do I have to test? I think this is really where the issue starts. So if I'm really talking about, let's say, some emergency braking algorithms, what are the number of different test cases that can happen on Indian roads? So one thing that people in Europe have been doing is they try to categorize everything. So we've got the standard NCAP test cases, for example, or we only focusing on highway scenarios, highway with up to 120 kilometers per hour. These kind of things, people try to put this into categories. And hey, this is a cut-in scenario with this kind of amount of speed. This is the European and American people try and get an overview of what can happen on the road. But really there is no, I mean, you cannot put real world and put labels on there, just easy as that.
I think thanks for your thoughts on that. Maybe I'll put this question to Martin. Do you see, Martin, that you will need an industry-wide approach of consolidation of these different test cases or scenarios where the industry needs to come together to start standardizing? I'm talking from an India context right now here, because where is the starting point and how much do you do? How much is enough? For example, basis your experience of being in the testing and validation side of things in the European market, what would you propose to the Indian market, the Indian industry, in terms of standardizing or adding more test cases which become standard test cases which are relevant to the Indian market condition to validate these scenarios and to validate some of these systems, for example, basis your experience?
All our projects we have done in the past were every time based on accident statistics. So accident statistics is very important because if you have some cases and you don't know how many persons are killed in these situations or are seriously injured, This is every time the same. So in Europe, we have, in Germany, we had a very, very good accident statistics. And in our European projects, where we had the Italian and everyone, we saw that we have accident statistics, but no good data behind. So you need exactly what is the situation, what was the speed, what was the reason. And we have also in Europe, 80% are human failure and not technical failures. This is the same. So basically, for all things is a good accident statistics. This can only be driven by government and projects, research projects together, or from the police, some databases or something like that to catch every scenery. But you need then detailed data. So one question could be, is there any possibility to make a cheap black box in each car with some cheap camera that you can also see if there is something to evaluate out? This is in Europe now a must to have since last year, to have a black box in it, because if you enter some new technology, then you change also the situation. So you change the accident statistics. It's not every time the same. So if you enter mobile phones, new mobile phones, then everyone looks during driving. And this is maybe the main reason. So this is something what I think could be a good starting point. And then for sure, if you think on test cases, it's every time a minimum what we can do on the test track. Much more you can do in simulation from the amount and from everything. Or to vary parameters and so on. So this is also very important, because a Euro NCAP test can be perfect, 10 centimeters away, maybe nothing happens with the ADAS system.
This black box is a very interesting thing you're talking about. Is it similar to what you have in aircrafts, which keeps recording data, and then you have data to kind of, is that how it is working in Europe right now?
So black box is now in the UNECE regulation as a fixed point. And then if something happens, so the car detects an accident, then the data are stored. So it continuously storing data. Storing data, what the car is doing, what the sensors are seeing, what is the acceleration, what is the seat belt doing, what is the airbag ongoing, and everything. So that afterwards you have, if the accident takes place and the expert comes to the accident and analyze everything, then he is not allowed to take these data, because the owner of the data are the car driver or the owner of the car. And then you can take out this, and then you, if there is someone died during this accident, then the car driver has to give the data to the expert.
Understood. Thank you. Thank you for bringing that up, Martin. So we spoke about technology. We looked at sensors, hardware, software. Maybe for the next few minutes, we'll focus on the most other critical parameter from an Indian market perspective is the cost of the system, right? Maybe Bala, if I can ask you, what are your thoughts on how we can bring the cost of these ADAS solutions, keep bringing them down, right, for the Indian market? What are your thoughts on that? Can software help somewhere, or can we reduce the number of sensors as we get more and more confidence into these systems? How are you thinking about, or how is your organization thinking about this?
Yeah. So thanks to the new architecture that is coming up, so all the processing are going to be done at central computer, high computing platform. So if you look at in the past, so every sensor had its own computation, and then it sends the final perception output. That means that having all computation, having a dummy sensor and then sending data to the central computer, so there is an advantage because you are optimizing your resources, right? And that is the way to go, because with central computer, you are reducing the number of interfaces, you are simplifying your electrical architecture. That means that it's overall, the vehicle cost will come down. You can add the function, and you can also deploy the function anytime you want. See, for example, I release a function today with certain functionality, and with the central computer, with STV coming up, then I can also release at any time. And we all spoke about data pipeline, right? So the advantage that I have is that I collect the data, and then the training happens in the cloud, and then I have the solution ready, and then push the solution. So over the period, which means that the development cost also will come down, right? Because today we are talking about, it's not that, no, I have a 5 sensor, radar, camera, LiDAR, and this one. Having a four development pipeline running with 4 different suppliers. Now that is going to get minimized. Yeah, so that is going to get minimized with the simple interfaces, centrally with few suppliers, and sometimes even since the data owner itself going to be the OEM as such, that also leverages OEM to utilize the data and develop their own function. So eventually the number of issues come down, so that will have a cost reduction, and then the development interfaces are coming down, that will also have the development cost coming down.
Thanks, Bala. I think that's a very interesting perspective to think that the development cost will also come down. We don't think about that very often, but that's a very valid point. Aneesh, maybe if I can bring you in here to see what are the pathways of reducing the actual number of sensors on the vehicle in itself, right? I know today, I was at the CES this year, and there was one car which had 6 LiDARs and 8 radars and 3 or 4 vision systems and everything in the world that is possible. How do we need all of that, right? Even if you talk about autonomous driving, and how do we bring those sensors down? How do we do more with less, for example?
Interesting question. So the example you quoted are mostly, I would say, L3 systems, SAE L3 systems and beyond. So the cars which we see in India right now are mostly L2 or L1. So here, let's say in a typical L2 system in most of the cars in India, you have a radar and camera fusion system, that's it. So many of these, at least in the B segment, you can't afford central ECU processing with a lot of computing data. So in that context, I would say an L2 system is pretty affordable, at least for a B segment in India, and there are a lot of cars flying around already. Coming to the bigger question, so 5 LiDARs or more LiDARs, etc. So these topics are mostly, I would say, in the premium market for L4 or L3 kind of markets, which we will see after a lot of time in India. One thing which, one example we can tell is, again, the ultrasonics type. So from an OEM perspective, the whole system cost matters, not just the number or whatever. So the whole system cost, how can we control that? So intelligently working on this solution by a combination of sensor suite. So less number of sensors, less computing power, less wiring harness, and great time to market. So all these factors, if we can intelligently contribute towards it, then the overall system cost to an OEM will reduce. So as an example, this ultrasonics to radar is an interesting topic. So if you already have a radar suite, which is already cost competitive, we can eliminate some of the ultrasonics. And maybe, I don't know, maybe it's a thought process, maybe 4D radar can do some of the things which a LiDAR can do. And in combination with some of these aspects, together with the functions, we can reduce the system cost, maybe not the actual number of sensors, but the system cost, the total cost involving the computing power also.
Thanks, Aneesh. So you're also talking about how do you reduce the computing effort and therefore the computing power and therefore the costs associated with that. Understood. I know we are standing between lunch and the audience over here, so we'll try to wrap it up very quickly in the next 5 to 7 minutes or so. I'll request Sreeram for your closing thoughts on where do you see the future of ADAS in this market, and maybe one important takeaway for you in terms of how ADAS is going to progress in this market, or what we need to do to unlock that growth in this particular market. After that, we will open up to the audience for questions.
So India is a very interesting market, right? When ADAS was introduced in the mid-segment cars, and the basic assumption was that people would go for the lower end of the cars normally. But we see that there is quite some demand for the upper segment with ADAS features included as well. But having said that, we are also a very, very cost-sensitive market, right? Because the cost of component when it reaches the end customer is multiple times what the cost of the component is because of the way our structures are and so on, right? So having that in mind, I think keeping cost in mind as well as the aspiration of the customers, we should look for a solution that's scalable. In the sense, you could have a sensor in place, some amount of compute, which is also capable of having features added onto it over a period of time. And from my perspective, or my opinion, would be that one simple sensor would be a camera, right? Because if you have a video sensor, you could have a lot of basic features already implemented. And over a period of time, you could give more features which are maybe lane related, traffic sign related, traffic light related, and so on, which is all integrated onto the same sensor, but it's just software updates. And you just have to protect the compute, which is required so that you can give these features over time. And these would be the basic features, not necessarily with high compute and so on, but enough compute which makes the whole system scalable. And the other thing which would definitely drive the adaptation of ADAS in the market is this sense of safety that is coming into people, because there is this the big demand for 5-star crash-tested cars and so on. And as our NCAP requirements adapt and we bring in more ADAS features also into the NCAP ratings, more and more people would prefer to have cars with ADAS because they then relate it with safety, right? And the safety features would then take a priority in their buying decision. And protecting, having an architecture which protects the car to have more and more features integrated over a period of time, which is scalable, I think that would be the key to success.
Thank you, Sreeram. Scalability is a very important parameter to think about. So thank you, gentlemen, for your time and for your thoughts, for bringing out all your experience and educating us. We are also learning as we go along in this market. It's a new topic for us. And I'm sure we will make rapid strides with each passing year. And we will create our own solutions which are very, very unique to this market and which will probably also have some applications globally. With that, I would like to invite any questions from the audience. We'll try to stick to 3 questions at max. Yes, the gentleman at the back, if you can please pass on a mic to him, please. Sir, I'd request you to introduce yourself first and then your question.
Thanks. This is Ishwar Prasad. I'm part of Tata Consultancy Services, holding the position of Head of High Performance Computing. So it's a ADAS, which is it's a combination of the LiDAR, radar, data, high voluminous data, and sensor, and so on. It is creating huge amount of data to be processed. Okay. So one of the, Praveen, you asked the high performance architecture is involved or not. So Sreeram has answered for that as well. So the latest, the quantum computing is on the way. In a research perspective, how the ADAS intersect with the quantum computing in terms of sensing, in terms of processing, in terms of the AI training and so on. What is the future look of this technology while intersecting with quantum?
Sreeram, quantum computing.
I think it's a long shot, but I'll give it a try. So at least from what we read, it seems that quantum computing has an edge when it comes to all this probabilistic calculations, which is what we have in ADAS, right? And the challenge that we see today is that automotive, compute in automotive is very, very difficult because you have to look at all the electrical interferences and things like that which are happening in the vehicle, right? So the EMI EMC requirement for a compute device in the vehicle is quite stringent. But if the quantum computing reaches a state where it could speed up the model training process itself, I think that would be the first step where we would see this happening. But I would say it is much long way before it becomes an edge kind of a solution. So I would imagine this to happen first in the model training area, if and when it happens.
Yeah, so one of the option, I think, the quantum-inspired algorithms can train it in the classical computer itself by providing the quantum principle can be leveraged for the training. So is there any long-term vision or the short-term vision in the quantum technologies, leveraging the quantum-inspired algorithms?
Okay, so if you look, why this quantum computation comes, because we are talking about a lot of AI in ADAS, and that means that central inference has to happen in the central computer. I would say that this is already happening. The central computer, even the sensor, camera sensor with higher tops is already doing it. But then going forward, more and more, see, as Sreeram spoke about, we are not just talking about AI being in the perception layer alone, but then we are also talking about the other layers of the ADAS. That means that the higher computation it's going to have only increase. So going forward, how much it will be on the technological advancement, I have no idea, because we don't have representative from NVIDIA or Qualcomm. But then I see that that will be the future, because the more AI is playing a role in L3 or L4 driving. When they launch L4, it is most probably most of the work done by the AI.
I think you had us served with that question. We don't probably have an answer readily available for you right now. It is something for the future, something that will definitely be relevant in the future. How it will, what shape or form it will take, and where we will see that its applications is something we'll have to wait. I think Sreeram said it's probably going to start in the modeling, in the training of the data of the models, for example. But it's something we'll have to wait and watch in terms of how the industry evolves. Next question, please.
I have a question, actually. So one of the previous presentation mentioned...
Sir, if you can introduce yourself.
Okay. My name is Rajesh. I work as a global director for business development for Multicover. We are based out of San Jose. So my question is, why do we treat this predictive AI and rule-based AI mutually exclusive? Can't it go hand in hand? Because, and in the short run, I'm looking for an answer, and this is the key takeaway for me. In the short run, how can we make this successful, Because with the DeepSeek, we have proven that, with less we can do more. Training the data, is it so difficult for the Indian road condition? It's difficult. How, you six are sitting as experts here. How soon can we bring this for the Indian road conditions? Can you give an answer? And why these are not mutually exclusive? It should go hand in hand, Can you explain as well?
So AI and what else is not mutually exclusive? Sorry, the audio is bad here.
The predictive AI, I know the hardware challenges for the predictive AI, for LLM or transformation models, or, for the rule-based system, how it could all go together.
Right. Fabian, you... Okay, sorry.
Yeah, so it's not mutually exclusive. So the rule-based and the data-driven or the AI-based would definitely happen hand in hand. It's just that over a period of time, more and more rule-based methods are being replaced by a AI or a data-driven method. And that's because we see there is an improvement in performance of the function when you move to a more data-driven model of development. But as of today, the AI-based and the rule-based are working hand in hand. For example, in the initial systems, we have perception, which is more AI, whereas your driving policies are more rule-based. Your trajectory predictions could be more rule-based, right? And there could also be a scenario where we have a safety net, which is more rule-based, more explainable, rather than unexplainable AI-driven. But this is an evolving area, right? And we see that what we see is that bringing in more data-driven approaches into the different areas of the stack helps us improve performance. But it's not a mutually exclusive either rule-based or a data-driven approach. It's going to be together. It's hand in hand. The fundamental question that would come is that if you say that the rule-based becomes your safety net, and AI is giving you performance, at some point of time, there will be a disagreement between what the AI model tells you to do and what the rule-based tells you to do. And if you always override the AI with rule-based, your performance is always limited to what the lower performance is. And that's a choice that we'll have to take. It's an open domain, but as of today, it's not mutually exclusive, it's hand in hand.
I think to add to what Sreeram said, automotive is something, safety becomes critical, right? More than performance, safety takes precedence over everything. Therefore, even if your AI is giving you the performance in terms of the compute and so on and so forth, in terms of decision making, and if there is, especially if there's an intervention that is required, an automated intervention that is required, right? Safety takes precedence over there, and if that means that you have to fall back to the rule-based, you'll have to fall back on the rule-based, and you cannot use AI in there. And what Sreeram mentioned over here is them not being exclusive in the sense that you will use AI where AI gives you the performance benefits, say for example, perception, right? But if you have to use something else which is more safety critical and you cannot just rely on AI, then you'll have to fall back onto rule-based. So it's not mutually exclusive in that way. We have to pick and choose and find the right balance between performance and safety to make sure that we are driving it in the right way going forward. Okay? We have time for one last question.
Hi. Hope I'm audible. So myself, I'm Fabian Engemann. I work as product manager of fleet safety at Bridgestone Mobility Solutions. So first question is, ADAS is an emerging field, and the latest feature, in order to support the latest ADAS features, the sensors need to be equipped with the vehicle. For the new vehicles, it's understandable that it would come with the sensors to support the ADAS feature. But how about the existing vehicles? So how can we ensure that the existing vehicles can be upgraded with sensors to support the ADAS features? Because it's going to be a huge market.
Retrofitting ADAS, retrofitting old vehicles with ADAS features is what you're talking about.
Yeah.
Aneesh?
Good question. It's not an impossible task. I mean, if you go around the booths also, there are people talking about it. So basically, a warning system, any warning system is easily retrofitable. So if depends on the inputs output. For example, if you are tampering something with the brakes for an e-bar system or something, it's difficult. One, from a regulatory perspective, it's a safety topic. And second, there is no widespread industry consolidation on how this will work, etc. But if it's a warning system, it's definitely possible, technically possible. Many people have done that. If it's a real safety topic, especially on the emergency braking or something like that. So let's say if you want the data from vehicle dynamics, the IMUs, if you tamper with the brakes, different types of brakes, all those are the technical challenges. It is of course possible on a given scale. If we have the right scale and all, people would really do it. But again, the challenges would be the homologation related topics, the legal topics, etc. So technically, I would say it is possible.
Thank you.
I think with that, I would request we close this session and we move on to a more interesting part, which is the lunch, I hope.
Sorry, we have one more panel discussion, which is a short time.
Okay,
So
sorry.
after that
Can I think I would like to ask
Sorry,
a question
there's one
because
more
I've been
question, I
standing
guess.
for
So
quite some time. If I can ask a question to the panel, because I've been standing for quite some time and missed my chance to ask a question.
Please go ahead.
Yes. So I'm in the industry from past 25 years. I represent CARIAD India. We are part of the Embitel Technologies Volkswagen Group company. 20 years ago, I attended a similar technology panel where people were discussing how difficult was common rail technology in India. It was so expensive. The diesel fuel is really bad in industry. I'm coming to the question. Bear with me.
The audio is not clear. Sorry, 1 second. Can you do something about it? We are not able to understand it. Were you able to follow? No, right?
Can you hear me now better?
Can you please try it, but a bit slowly, please?
Yeah. Can you hear me now better?
Yeah.
Yeah. So my name is Raja. I'm representing CARIAD India. I'm part of Embedded Technologies of a Volkswagen Group company. I'm here in the industry from past 25 years. 20 years ago, I attended a similar panel discussion where a group of people were discussing how difficult is common rail technology in India, how difficult is diesel fuel in India. Then a group of OEMs and suppliers and technology partners came together and decided that 1.3 liter multi-jet fuel injection engine is like a platform engine for the entire market. And the entire myth of technology and challenges and cost was busted instantly because group of consortium-based members came together as a technology solution. So if you had a chance to work as one community, would your approach for ADAS solutioning for India would change? Would your technological challenges and approach would change? If you had, let's say, 70 to 80% of the market coming together and solution it.
Thank you for that question. Because the audio is not clear, I'll try to rephrase the question or I'll repeat the question. 20 years ago, with respect to powertrain technologies,
it's just a parallel about how consortium-driven approach and a group, everybody coming together as a community can bust the challenges of what we can do together rather than what we can do separately as sensor supplier, compute supplier, OEM supplier, AI supplier, test supplier, like that. Instead, a consortium or a group-driven approach would change your solution.
Understood. So, thank you for the question, well noted. Absolutely, there is a potential for a consortium kind of an approach for people to come together to bring their resources, their forces to make this happen in this particular market. No doubt about it. And the example that you gave about powertrain systems is definitely very well documented in terms of how different players had to come together to make it happen. The one challenge I see with respect to ADAS here in India and the uptake of ADAS is, from a technology standpoint, Tier 1, Tier 2s, OEMs, system integrators, and all of that, that is probably they're already beginning to work together. From my perspective, what little I have seen, and some of the speakers have also alluded to it in the previous conversation, is the infrastructure, right? The infrastructure, the road infrastructure, which enables ADAS in a more meaningful way. I think that becomes a very important stakeholder in this entire equation. If you take the same parallel of the powertrains, of how the powertrains worked in the past by bringing the consortium approach, we will need a significant push on the infrastructure in terms of upgrading our infrastructure so that they become ADAS ready, so that they enable ADAS in a more meaningful way in this particular part of the world. That is point number one. The other difference I see to that example is that ADAS will also make more sense if there is also more, let us say, enhanced sense of civic responsibility from the drivers, right? Rules have to be followed, and that is where ADAS becomes more and more important, right? You cannot develop systems and ADAS, successful ADAS models, if people do not have a regard for the basic rules that are to be followed when you're, in a motoring world, for example. So these two will be the fundamental challenges on top of what was already achieved as a consortia approach. If you can also include these two stakeholders in addition to the industry as a part of that consortia you're talking about, absolutely there is a lot of work to be done, and absolutely we will see much better results going forward. Thank you.